Hello friends, welcome to my video blog. This exercise is about the Windows clustering, where due to the hardware failure on one server, the standby server takes over all its operations, ensuring the smooth continuity of the business processes as usual. In this example, we will simulate the failover of a DHCP server from one server node to the standby node. Clustering is mainly used in an high availability environment in order to avoid a single point of failure. In the most cases, the latency during the failover is marginal and the failover itself is transparent to the connected clients or users. Clustering is an advanced topic. Therefore, the prerequisite of this exercise is that you have good knowledge of VMware Workstation. This whole demo runs in the nested virtual machines on a Workstation version 11, but one can use Workstation 9 or 10 also. Further, it's required that you are capable of configuring the Active Directory domains and are able to make the other computers member of that domain. It will help a lot if you are familiar with the Windows networking troubleshooting tools such as ping, ipconfig, tracert, etc., and are also familiar with the protocols such as TCP/IP, iSCSI, CIFS, NFS, etc. So let's get started. This is how our lab scenario looks like. We will need in all 5 virtual machines, 1 virtual machine for the domain controller and 2 virtual machines for each cluster nodes. The 4th virtual machine will run the FreeNAS where the iSCSI shared storage in the form of 2 disks, namely the quorum and the DHCP data disk will be configured to share them between the 2 cluster nodes. The 5th virtual machine will run the XP to test that at the boot time it gets its IP from the DHCP standby node server after the failover is implemented. These are the software bare essentials. We will need VMware Workstation software to run all the nested virtual machines. In the real world scenario, a switch is necessary, but in our case, the workstation itself will act as our switch. Both the nodes and the FreeNAS will be equipped with 2 network interface cards and 2 shared disks each. The domain controller will have a single NIC. We will add 2 networks, namely the NAT and host-only types, to the workstation. Then we will associate the NAT network to the first NIC that will be used for the management console and will have the IP address of 192.168.5.x, and the second NIC will have the IP 192.168.2.x, and its network type will be the host only, and it will be used for the iSCSI data traffic. We will need to install the role of domain controller on the first VM and will create a domain called clusterdom.local. The 2 nodes will be then added to this domain as the member servers, and then we will install the cluster failover feature on both these nodes. On the 4th VM, we will install the FreeNAS SAN storage software. Then we will configure 2 disks for the quorum and the DHCP cluster data that will be shared between the 2 nodes. Now we will start with the installation and configuration of the Active Directory domain controller on our first VM. I have already installed and configured the domain controller and created a domain called clusterdom.local. Therefore, I'll show you my configuration in the following slide. So these are the 4 VMs which I have configured The first one is the domain controller, the second one is the node 1, and then the node 2 and the freeness. The configuration of the DC is simple. It has one hard disk and one network card. The configuration of the node 1, node 2 and free now is the same. So the only difference between the DC and the rest of the three VMs is that they have two extra disks. These are the iSCSI disks. The first one is the quorum, the second one is the cluster data disk. So these will be shared among the node 1 and node 2. And then all the three have two network cards. The first one is the NAT type and the second one is the host only type. And the first one will be used for the management console. The second one will be used for the iSCSI traffic. Next, we will need to create an enterprise domain admin account. This admin account is needed to join both the DHCP failover cluster nodes or the member servers to the domain clusterdom.local. So I will log into the domain controller. As you can see that I have already created an enterprise admin account. In my case, it's called the cluster admin account, and I will log into the domain controller and show you in the Active Directory users and computers that this enterprise admin account exists there, and the groups that this account is a member of. In this case, these are the groups which I made the enterprise admin account the member of. They are actually similar to the administrator groups. So I come out of here and then I will log into the node 1 as cluster admin account. In your case, since you are not a member of the clusterdom.local domain, you will first log in as a local administrator and then first join it to the domain. In my case, it's already joined, so it's very simple. What you need to do is go to the system properties and then change. And before you make it a member of the domain clusterdom.local, it will show here work group, and then after you have joined, it will ask for the password of the enterprise domain admin account, and then you will be able to join this node 1 or make it a member of, as it says, of the domain clusterdom.local. After it has become the member of this domain, then you will again log in to this back into the node 1 as enterprise domain account, and then you will need to install the DHCP server. DHCP server is a role, so all you need to do is click on server manager. In my case here it's called server manager on node 1, right click, add role, and then click on DHCP server, and then accept all the default options. Give it a name, and like my DHCP it will ask, and then this member server or node 1 will become a DHCP server. After the DHCP server is installed, it will appear under the roles, and in my case, as you can see, it's here, and I have given the scope, the name cluster scope, and I have chosen the IP address range between 200 and 225, which any client that will now boot into the network, it will contact this node for the IP address, for the DHCP IP address, and it will get an IP address between 200 and 225. And I have changed the lease time to 15 days. You can change it to any day you like. Further, I haven't done anything. These are all default options. Only you need to give it a name and the start IP address and end IP address. That's it. And then there is nothing here, no reservations, as I didn't want to make it complicated, but you can reserve the IP addresses which you do not want to be distributed. We come out of here, and then we will install the feature which is called Failover Cluster Manager. So to do that, it's again, you have to go to the server manager, right click. Now this time you will have to right click on the feature, because the failover is a feature, clustering is a feature. So you can see in my case it's grayed out because this feature is already installed. Again, you have to check in and then choose all the default options, and this will be then installed on your node 1. So we go to the Failover Cluster Manager, which will now show the name of my cluster. I have given it the name my cluster, which is then part of the cluster dom.local. So there are 2 nodes in this cluster, as you can see, and this is the second node, this is the first node, and these are the cluster networks. They are the internal networks which the cluster creates, and they have their own IP addresses. So here the cluster network 1 has the IP address 2101, and here it has again the IP address which is public IP address, which is 5101 for the node 1, and for the node 2 it's 5102. This is a single IP address because this is for the data traffic. For the management, there are 2 different IP addresses. As you can also see here, there is a private IP address and the public IP address, and this is what the in case of the failover the IP address will remain the same for the data traffic. So this is all I have done here as the configuration for this, and after this it will ask you to validate a configuration, and then you can validate a configuration. It's fairly easy. It will test all the configurations, and then if it is successful, if everything is green, then you can go ahead and create a cluster. Next we will configure the FreeNAS storage. In my case, I have downloaded the free version of FreeNAS 9.3. The installation process is pretty straightforward, so you can install it like any other operating system. It's all the default options you have to choose, and nothing to configure there. The configuration starts with the web user interface, where we will access the FreeNAS from the web on the IP address 192.168.5.200. As you may remember that the second disk is 192.168.2.128. This network is host only, and it is meant for the iSCSI data traffic. So what we will do is, in order to manage this FreeNAS, we will now access it from the web. Before I do that, I can show you the two disks. You may remember these are the two iSCSI disks. One is the quorum and the second one is the DHCP clustering disk, which are shared. So those are on the accessible on from this network, which is 2.128. So we'll go over to the web interface now and access this FreeNAS http 192. So this is the number 200, and we are in because the default username and password was root. So now here only two of the options which are interesting. The first one is the services. So first you have to check that the iSCSI services is on. If not, you have to put it on. Secondly, you go to the iSCSI, and here I have already configured it. So here the first tab, you don't need to do anything, and you have to choose here the block iSCSI. If it is Windows share, then you need to do the CIFS. If it is Unix, then NFS. So in our case, it's block iSCSI because it's SAN disks which are being shared between the nodes. Now the portals is pretty straightforward. You just need to name the comment portal 1 and no IP address, because we are choosing all the ranges of the IP address, but the port number is important. Then we go to the initiators. In this case we choose all and all authorized initiators. Initiators are the servers, which are the, in this case, are the nodes 1 and nodes 2. Then we go to the authorized access. We don't need to, but we can use it if it is a production environment. Then are the targets. Targets are the disks on this server, on this FreeNAS server. So you have the target 1, and then you portal group is portal 1, and that's it. And then you go to the extent. Extent are the files or the volumes. In this case, files, sorry, which is quorum and data. So you have to now configure here, browse and configure volume on the volume 1 and volume 2, add these extents, and then you have to associate the extents, the LUNs, targets and the extents. So you just choose target 1 with the extent 1, which are the disks. Here it is the volume, and here is the file which I have created, forum, and that's it. There is nothing much to do here. And further, the second important option is the volume. So the volume 1, to add a volume, you need to go to the volume manager, and then you can put the volume name and then add volume. You can also do this manual setup here. Then let's say if you want to, if we had a third disk on here, let's say if there was a third disk, we have only 2 disks and both are now part of the this iSCSI targets. So let's say if we had a third disk, then we would name it volume 3, and then we will do the same sort of configuration as we have done here. Next, we will test the failover scenario. We will fail the current node, which is acting as the DHCP server for distributing the dynamic IP addresses to the XP clients. After the failover to the standby node, the DHCP services will be up and running without any delay. That means the standby server or the node will take over all the services. So we go to the node 1, and this is the node 1, and we see that currently there are no client IP addresses distributed, as there are no XP machines here on top to be seen. So we go to the node 2, and we see the same thing here. There are no client IP addresses distributed. DHCP dynamic IP addresses are not given away. So we go to the failover cluster manager, and we see that the current host which is acting as the DHCP server is node 2. So we go to the node 1, and then we see that it says the same. Current host server is node 2. That means a current node 1 is standby node, and node 2 is the acting or active node. So we go to the we boot up the one XP client to see if the IP address is given to it dynamically by the node 2, which is here. So we go here and we refresh. Currently it's booting, so we cannot see any IP address given to it. So we go to this computer name is SAP 200, and then we go to the network settings, and we see that it has no pre-configured static IP address, so it is waiting for the dynamic IP address to be given by node 2. So we go to the node 2 and refresh, and it has given the IP address 5.200 to SAP 200. So we go back to the SAP XP machine and we check the IP config, and we can see it has been given the 200. And then we go to the next second machine, which is SAP 100, XP SAP 100, and then we boot it up and check if node 2 is giving it again IP address. So this is SAP 100 XP, and then we will fail the node 2 and we go to the name of the computer, which is SAP 100 in the Indeed, and we go to the network settings, and we see that it has the no pre-configured addresses. So we go to the IP config, and this is given 202. We go back to the node 2 and then refresh, and we see that this is the address which is given. So then we fail this, we power it off, and this one is gone, and now we will see that the current host server is changed to node 1 because it has immediately taken over the services from the node 2 as application services. So it also says these are the two addresses are here still, and we go to the SAP 100 and we check the address is the same, and we try now to go to the internet to see if everything is working. So it's working, and so it means everything is working fine here. Then we go to the SAP client to SAP client 100, and it has still got the IP address, and then we go to the internet to prove that everything is working. It's already showing the internet. So that's it. Now that proves the point that the failover from NAS from a failover from node 2 to node 1 worked very fine. We can see that there is only one node up, and the node 2 is down, and all the services are working fine.